The greatest common factor of two numbers is the largest factor that they both have in common. If I have 8 hens and 6 chicks, do they have a factor that's in common? The answer is yes. 2 times 3 equals 6, and 2 times 4 equals 8, so 2 is the greatest common factor, or GCF. The difference of squared binomials is an expression where two perfect square terms are being subtracted. We are going to use the equation 16 minus 4w squared. The square root of 16 is 4, and the square root of 4w squared is 2w. So 16 minus 4w squared gives you, in parentheses, 4 plus 2w and 4 minus 2w. Perfect square trinomials are a three-term expression where the first and last terms are perfect squares and the middle term is twice the product of the square roots of the first two terms. We are going to use the equation j squared plus 10j plus 25. So let's see if this equation fits into a perfect square trinomial. Our first term is j squared. The square root of j squared is j, so this fits in. Our last term, 25, its square root is 5, so this fits in too. Now the middle term is 10j. To find out, we have to take the square root of the first and last term, which is j and 5, add them together, and multiply them by 2. So 5j times 2 equals 10j. So this fits in. So this is a perfect square trinomial. Factoring trinomials. We're going to start with the equation d squared plus 9d minus 10. How can we solve this? First, let's look for the GCF. Looks like there isn't any here. So the next step is to determine the binomial factors. The first term would be d in both parentheses since it is d squared. To find the second set of numbers, we need to find the factors of negative 10 that when added equal 9. The factors of negative 10 are 10 minus 1, 1 minus 10, 2 minus 5, or 5 minus 2. Which two factors when added equal 9? The answer is 10 minus 1 equals 9. So we found our second set of numbers for the binomial. Let's plug them in. D squared plus 9d minus 10 gives you, in parentheses, d plus 10 and d minus 1. The equation we shall use for factoring by grouping is 3s squared plus 8s plus 4. This isn't a perfect square trinomial and it can't be factored like one. What do we do? The answer is make it into a 4-term polynomial. To do this, we must split the middle term, and how we do this is by timesing the first term by the last term, so 3 times 4 is 12. Now we need to find what factors of 12 when added equal 8. 1 plus 12, 2 plus 6, and 3 plus 4. 6 plus 2 equals 8, so we have our factors. The equation now looks like 3c squared plus 6c plus 2c plus 4. Now we group the terms. We group the first two terms and the last two terms. So in parentheses we've got 3c squared plus 6c, and in the other one we've got 2c plus 4. Now we are going to factor these two parentheses separately. So the first one can have a GCF of 3c, and that'll leave it at c plus 2. And the second one, you can take the 2 out and it'll be c plus 2. What do they have in common? In parentheses now is the same thing.
So this makes one of the binomial factors, c plus 2. And the second one is the GCFs of the groups. So 3c and 2 make up the other binomial factor. So now we have, in parentheses, c plus 2 and 3c plus 2. And that's how you factor by grouping. Sums and differences of cubes. The equation we will use for this one is 4p cubed plus 2048. The first thing we can do here is find the GCF. 4 can be divided from both 4p cubed and 2048. So the answer is 4 and in parentheses p cubed plus 512. Both p cubed and 512 are perfect cubes. P cubed is p and 512 is 8. Since they are being added, they will be plugged into the sum of cubes equation. A cubed plus b cubed equals, in parentheses, a plus b, and the other parentheses, a squared plus ab plus b squared. P cubed plus 8 cubed equals p plus 8, and p cubed minus 8p plus 8 squared. And now we simplify. P cubed plus 512 equals p plus 8, p squared minus 8p plus 64. And that's our equation.